Okay, so we already talked about how to solve systems algebraically using substitution. That was the first day of these notes. So we did those couple examples, and then we also talked about if the variables disappear and you have something like 0 equals 0 or 4 equals 4, that's a true statement. We know there are infinitely many solutions, and the type is dependent. If you have a solution that looks like 0 equals 10 or 2 equals negative 2, something that's not true, then our solution is no solution, and the type would be inconsistent. So we're going to continue these notes today and talk about elimination. And the first step for elimination is to line up the variables, constants, and equal sign. So line up the variables, which are x and y, line up the number, and line up the equal sign. So you might have to manipulate your equations a little bit, move x to a different side, move y to a different side, move the number to a different side, and make sure the equal sign is all lined up. Step 2 is to multiply one or both equations to have opposite coefficients for one variable. So in one equation you might have 2x, in the other equation you would want negative 2x. So you'd have opposite numbers, so like 2 and negative 2 or 4 and negative 4, those are opposites. You want opposite coefficients, that number in front of the variable, for one of the variables. If you need to pause and finish copying these down, make sure to do so. Step 3 is to add the equations together. When you do this, one of your variables will eliminate. If you have negative 2x plus 2x, there are no x's left. That would be 0x. 0x is just 0, so you don't have to write it. So adding the equations together will eliminate a variable. Next, you're going to solve for the variable that's left. If you eliminate x, you'll have only y in the equation, and you have to solve for y. If you eliminated y, you'll have x in your equation to solve for. So there will only be one variable to solve for. So number 4 is to solve for the variable that is left. For step 5, you're going to substitute the known variable into either original equation and find the unknown variable. So if you have x now, you'll plug that into one of the originals and solve for y, or vice versa. Step 6 is to, now that you have both the x and the y, you're going to write the solution as a coordinate point. So your coordinate point is written as x comma y. And the last step is to check your solution, just like we did with the substitution. Now, we do have a couple examples that we're going to go through together. So, example. For example, this is example type 2. Solve each system by elimination, check your answers, and state whether the system is independent, dependent, or inconsistent. You're going to get in the habit of every time you solve a system, you're going to mark it as independent, dependent, or inconsistent. Remember, if it's independent, you'll have one solution. So your solution would look like this. If it's dependent, you'll have infinitely many solutions. And if it's inconsistent, you would have no solutions. So just remember those couple things, because that's how we are going to know which type of system it is. And that was back from 3.1. So A and B on this very first example. You'll notice that your x's are lined up, your y's look to be lined up, and your number signs are lined up, but your equal signs are not lined up, and they all have to be lined up. So for A, what we're going to do, and I always rewrite these together. So A, I'm going to move the 3y to the other side, like it's like this one. So my equal sign and my 3y are going to change spots. In order to do so, I have to add 3y to both sides. So I'm going to get x plus 3y equals 7. Now for B, I'm going to leave that one alone for right now. I have 2x minus 4y equals 24. So step 1 is done. To line up the variables, x and y are lined up, the constants are lined up, and my equal signs are now lined up. It says to then multiply one or both equations to have opposite coefficients for one variable. My coefficients here are 1 and 2. Those are not opposites. Here we have 3 and negative 4. Those are not opposites. So you can choose. Do you want to eliminate x or eliminate y? There's not a right answer here. You get to choose. I would choose x. The reason? Because I can easily multiply this by -2 to make those opposites. I can't multiply by 3 by anything to make it a +4. I would have to multiply both of these and turn them into 12. I'd have to multiply this by 4 and this by 3. So I'd rather only do something to one equation. So what I'm going to do is I'm going to multiply this top one by -2. You may remember this from Algebra 1. So your A equation is now -2x minus 6y equals -14. And your B equation has not changed, but I'm always going to rewrite them together, A and B together, because it's just a lot easier to keep track of your work that way. 2x minus 4y equals 24. All right, so my variables are lined up. I multiplied one of my equations. I now have opposite coefficients for one of my variables, -2x, and 2 are opposite, so I'm good there. Then it says to add the equations together and eliminate a variable. So I'm going to add. My equal sign is going to keep them separated. -2x, I'm adding like terms together. -2x and 2x go away. They eliminate because it's 0x. That's nothing. -6y and -4y is -10y. -14 and 24 is 10. Next it says to solve for the variable that is left. So you're going to keep going with this equation. Divide by -10 on both sides. We'll get y equals -1. Now we solved for one of the variables. Now that we have y, our next step, step 5, says to solve or substitute the known variable, which is y, into one of the original equations. So we can plug it into A or B and solve for x. I'm going to choose to plug it in to A. It does not matter which one you plug it into. So here we have x equals -3, y we know, plus 7. The y that we know is -1. Now I'm going to solve for x. X equals, that's 3 plus 7. X equals 10. Okay, so I solved for the unknown variable. Step 6 says to write the solution as a coordinate point. So my solution has to be a coordinate point. The x is 10. The y is -1. I'm going to make sure I put them in the correct spots. I also need to state the type. And since I had a solution, that's an independent system. Now when you go to check this, it's the same way that we checked it the other day with substitution. All we're going to do is the left side was x, so I'm going to type in my x, 10, equals. So my answer for the left and my answer for the right have to match. My right side is -3 times the y value is -1 plus 7. The right side is 10. I have 10 equals 10, and it works in A. In order for it to be a solution to the system, it has to work for both A and B. So let's try B now. I'm going to clear it so I don't get confused. 2 times x is 10 minus 4 times y is -1 equals, the left side is 24. The right side was just 24. 24 is the left equals 24 is the right. It worked in B, and because of that, I did it correctly. All right, let's try the next one. The next one says to line up the variables. I'm going to go back to step 1. Line up the variables x and y. X is lined up, y is lined up. The numbers are lined up, and the equal sign is lined up. So step 1 is already done. Then it says, multiply one or both equations to have opposite coefficients for one variable. I could multiply one of them by a -1 to get to a -2. But if you look, I already have 5 and -5. So step 2 is already done for me as well. I can just add the equations together and eliminate a variable. So I add these together, and 5y and -5y eliminate. I'm left with 4x equals 0. That's okay. I'm going to divide both sides by 4. And I get x equals, if you're not sure what 0 divided by 4 is, that is one that you can type in the calculator. The answer is 0. Or go back up to here. 4 times what number gets you 0? 4 times 0 would be 0. X has to be 0 there. All right, so we solve for the variable that's left. Substitute the known variable into either original equation and solve for the unknown variable. So at this point, you can plug it into A or you can plug it into B. It does not matter. I did A last time, I'll do B this time. 2 times x is 0 plus 5y equals 20. 2 times 0 is 0. So I just have 5y equals 20. Divide by 5 on both sides. Y equals 4. All right, now I have x, I have y. I'm going to write my solution as a coordinate point. X was 0, y was 4. And the type, because I was able to come up with a solution, is independent. Next, what we're going to do is we're going to plug them back in to check them. So our top equation was 2 times x is 0 minus 5 times y is 4 equals negative 20. That one, it worked. I could type in the right side, negative 20, but it's already equal to it. There was nothing to simplify there. All right, let's try the bottom equation. 2 times 0 plus 5 times the y was 4 equals 20. 20 equals 20. I'm good to go with both A and B, so my solution must be correct. For the last one, and you can even put a little check there because we checked it. I'll do that in the green since green was check your solution. The last one. Okay, so we're going to line up our variables. Looks like x and y are already lined up. We're going to line up our numbers. They're lined up. Equal signs are lined up. Step 1 is good to go. Multiply one or both equations to have opposite coefficients for one variable. Doesn't matter. Do you want to make the x's opposites or the y opposites? It's your choice. Maybe you want to make the x's opposites. And what you do is negative 3 can turn into 12, so I'm going to multiply this by 4. A is going to become negative 12x minus 32y equals 48. The b is going to stay the same. I haven't done anything. So 12x plus 32y equals negative 48. Next, we add the equations together to eliminate the variable. When we go to do this, we set it up so x is eliminated, and it just so happens that your y's also eliminate. If everything eliminates on one side, you're left with 0 on that side. And on the right side, well, shoot, everything also eliminates, so we're also left with 0. 0 does equal 0. We can't even follow the rest of these because there's not just one solution. There's either no solutions or infinitely many solutions. So in this case, when you have a true statement, we know that that's infinitely many solutions. And the type is dependent. So we'll fill that in down here at the bottom as well. It says when there are no variables remaining and the statement is true. So for example, we have something like 0 equals 0. Then our solution and the type we have to write still. And the solution is going to be infinitely many solutions. And the type is going to be dependent. Now, if it is a false statement, example, 4 equals 0, or anything for that matter, equals a number that it's not equal to, we have to still write our solution and the type. And the solution here is no solution. And the type is going to be inconsistent. And that's all I have for you today.